All right, class. So here's another application of the integral. We can use it to find the volume of weird shapes. Okay. So the idea here is I'm not going to go through tons of detail because it's really hard to explain. Trying to do it on a chalkboard, where I can move around and try to do things in 3D. But doing this video, you can't even see what I'm pointing to so much, so it's going to be tough. So I'm going to just try to do this example. I will have already introduced it in class, so here's just another one where you can watch the calculus steps. Okay, so if we read this problem, find the area of the solid with a circular base. All right, so this right here, even though it looks like an ellipse, it's a circle. It's just trying to look 3D. And then the cross sections, so what's coming out of this circle, so the base is a circle, and coming out of the circle are triangles, where the base of each triangle is equal to the height of each triangle. Okay, so the triangles on the side are shorter than the triangles in the middle. Okay, so let's remember, hopefully I've told you this in class, is that if we integrate over the function that gives us the cross section of each, of each shape, in this case triangles, if we integrate that from the lower limit to the upper limit, that should give us the volume. Okay, so in this case, the cross sections are triangles. So 1/2 base times height gives us the area of each cross section. And now let's figure out what is the base and what is the height of each triangle. And notice it's a function, so I'll have it in terms of x. Okay, so I'm going to un-3D this because it's a little bit confusing. And let's just look at the circle. Okay, so for each triangle, the base, the base goes from one edge of the circle to the other edge. Remember the equation for a circle? Equals radius squared, but in this case it's just 1, right? Because the radius is 1. Okay. So if we want to know the length of this, it's going from one edge to the other edge. And so let's think about, what these functions are. If we get it in terms of x, right? So y squared equals 1 minus x squared. Y equals plus or minus the square root of 1 minus x squared. Remember, the plus square root gives us the top. The minus square root gives us the bottom. Okay, so hopefully you can see the length here is 2 times the square root of 1 minus x squared. And since the base equals the height is also 2 times the square root of 1 minus x squared. Okay, so the function for the cross-sectional areas is going to be 2 times 1 minus x squared. Okay, so that's our function that gives us the cross-section of each triangle. Okay, so let's double check. Let's see the triangle that's right in the middle. Okay, so the triangle that's right here, its x-coordinate is 0, right? So let's plug in 0. 1 minus 0 squared is 1. 2 times 1 is 2. And that's good, right? Because here the base should be 2. Since this circle has a radius of 1, we got 1 on the top, 1 on the bottom. Okay, so it seems like we're probably in good shape. Okay, so let's load that in. That's our integrand. We're integrating with respect to x, so we need limits with respect to x. All right, so this circle goes from negative radius to positive radius, so from -1 to +1. Okay, quick note, we also could have done 2 times the integral from 0 to 1, right? Since it's symmetrical, we could have done the volume over here and then doubled it instead of finding out the volume of the whole thing. But we're all set up here, so let's just go with that. All right, so this is going to give us the volume. So the volume is the constant, goes out front. The antiderivative of 1 is x, and the antiderivative of x squared is 1/3 x cubed. And we want to evaluate this from -1 to 1. Okay, so the volume is 2 times 1 minus -1 minus 1/3 times 1 cubed minus minus -1 cubed. All right, so let's clean some stuff up. 2 minus 2/3. So 2 minus 2/3 is 4/3, but we got to double that, so that's 8/3. All right, so the volume of this figure over here, this confusing three-dimensional figure, is 8/3 units cubed. All right, I know this is confusing. I just wanted to throw another example at you, but we'll do plenty of these in class. All right, so if you have any questions, please write them down. Take it easy.